Good morning, friends. My name is Saniro Kumar Sasikan. I was completed my MSc Applied Physics from MS University of Baroda in 2011. Then I am recently working as a PhD student and a school teacher in a private school in Vadodara. So today we are discussing about the one of the best things, that is what is acoustics. So first, to understand what is acoustics, so first we understand that how sound is classified. So sound is basically classified in three parts. Number one, infrasonic. The frequency is less than 20 hertz. Now, if you get the first question, that what is sound or how this sound is produced? So basically, sound is it is a wave. There are basically two types of waves are there that we can discuss in later this chapter. So first you consider this sound is a one type of wave. Now the next question arises, then what is wave? So if you consider any body or any place, if we disturb this place, then the wave is produced. So this disturbance or this force is either two type. One is either parallel to the surface, or second is perpendicular to the surface. If a force is parallel to the surface, then it will produce, there is no, the wave is produced, that is called vibration. But if a longitudinal force is applied, then and only then the sound is come out. So basically sounds are basically three types. First one is infrasonic. The frequency is less than 20 hertz. Now in your mind, that what is frequency? So frequency is, if we consider a one particular point, and this point, the vibration is taken place in one particular minute, one particular second, that is called frequency. In our case, we are considered as a second. So the infrasonic means the sound wave which are only vibrate this particular point less than 20 times. This phenomena is called infrasonic. Second is audible range. Audible range means we can hear the sounds. So this frequency is between 20 hertz to 20 kilohertz. This frequency is called audible frequencies. If you going to hear the different channel of your TV, if you start your television, then how much frequency is operated for a one particular TV channel? So around, if we consider that 200 hertz or 500 hertz or more than that, frequency is required to operate a one particular channel. Same thing, FM things. FM radio is there, short wave radio is there. So in that particular case, the frequency is 92.7 what big FM. So what is this means? 92.7 kilohertz or megahertz frequency is there. What do you mean by a kilohertz? That means 1 kilohertz equal to 1000 frequency, and 1 megahertz equal to approximately 10 to the 6 power frequency is there. So this is called the audible range. Third range is called ultrasonic. The frequency greater than the 20 kilohertz, which is called the ultrasonic frequency. So this is all about the classification of the sound. Next, we are going for the two types of sounds we are day-to-day lives here. One is called musical sound and second one is called noise. What is musical sound? The sound which is produce pleasuring effect to our ear, that sound is called musical sound. What do you mean by a pleasuring effect? So if you hear one more time, two more time, three more time, or n number of times, so this phenomena is called musical sound. Second phenomena of the sound is noise. The sound which do not produce pleasuring effect, this phenomena is called noise. So next thing we are discussing about this, the characteristics of the musical sound. Now you can perfectly know that what is the musical sound. The sound which you can hear so many times or which produce the pleasuring effect to your ear, this sound is called musical sound. So next our thing is that we can discuss about the musical sound. So there are mainly three characteristics of musical sounds are there. Number one is called pitch. So in this pitch, frequency is same, but the intensity is different. So in our first case, we should discuss already frequency. Now in your mind that what is intensity? So how intense you are that is called intensity is means what? If I am considering a particular area or particular volume, so in this volume how much amount of sound wave spread, this is called intensity. So if we, what do you mean by a pitch? So pitch is what? Frequency is same, but what is different? Intensity is different. So if we can clearly distinguish between the two waves produced by two different people, but we cannot distinguish between the two waves produced by the two children. So if we consider the example to understand the pitch, so if a two man or woman is talking with each other, then we can clearly say that this voice is from man and this voice is from woman. But same thing if we consider that two children, small kids like 3 to 4 years talking with each other, we do not distinguish between their voice. What he or she speak, we do not distinguish. Why? Because their intensity is low. So this phenomena is going to take place because of the pitch is there. Second phenomena is the loudness. So if you hear that, how loud you are, why you are so loud, this type of phenomena you are here in your day-to-day life. So what do you mean by a loudness? So it is the degree of sensation produced on the ear. That is, your ear is how much sensible that is given by the loudness. So the formula of loudness is L is directly proportional to log 10 base of I, where L is loudness, I is the intensity. If we remove the proportionality, then the proportionality constant K is come in the picture. So our formula is L equal to K log 10 base of I. So if intensity is increased, the loudness is also increased. If intensity, that means what do you mean by intensity? We first discussed that if we consider the volume, how much amount of sound spread over it, that phenomena is called intensity. So loudness means what? If intensity is increasing, the loudness is also going to increasing. If intensity is decreasing, then the loudness is also decreasing. Third quantity of the musical sound, that is called quality or timbre. So in this quality or timbre, the frequency is different, but intensity is same. what is going to happen? Frequency is different, but intensity is same. In our first case, that is called pitch, frequency is same, intensity is different. In our second case, loudness is different, whereas quality or timbre in particular way we are considering, frequency is different, but the intensity is always same. So this is called quality or timbre. So if we can play any musical instrument, then difference between the two sound waves, that is two different musical instrument, frequency is different but intensity is same. So this phenomena is called quality or timbre. So this is called the quality or timbre. This is called the characteristics of the musical sound wave. So now your picture is clear. What is acoustics? So acoustics is the branch of sound wave which are used by the civil engineer or architectures to develop the particular building or to develop the particular things. Wherever the sound waves are there, to control or to destroy the sound wave in extra amount, then at that particular time the branch of acoustics is come in the picture. Now we are considering the third part, that is called the absorption coefficient K. So what is the absorption coefficient K? So K is equal to sound energy absorbed divided by total energy incident on it. So if I am considering any material, then that solid material have some phenomena, that if a wave is strike on it, then the some amount of waves or energy is absorbed and some amount of energy is reflected. So what absorption coefficient K determine that how much amount of energy absorbed divided by total amount of energy incident on it. So the unit is Sabine. What is the unit is Sabine, and Sabine is that energy absorbed per meter square, or the unit is open window unit. Next phenomena is called the reverberation. Reverberation is the phenomena produced when sound wave which here after the source of sound is cut off is called the reverberation. What do you mean by a reverberation? It is a very important phenomena for the sound waves or for the acoustics. What is reverberation? If a source is going to stop, then further you can hear the sound wave. This phenomena is called reverberation. In this particular thing, what is going to happen? Source is going to stop, but you can clearly hear the voice. This phenomena is called sound wave, or this is called reverberation. Or time taken by the sound to fall below the minimum audible level after the source is stopped sounding is called reverberation time. So we can hear that if I am speaking from here and reach up to the doorstep or at the windows, there is some amount of time is required to reach my sound to that particular region. This time is called reverberation time, and with the help of this reverberation time, all the auditoriums or cinema halls or the multiplex or any of the things is going to produce or make by the civil engineers and the architecture engineers. So Next thing is the degree of sensation produced on ear is called the loudness. That is, you can hear that it is varies from the listener to listener. Loudness is also vary from listener to listener. So if I am giving the simple example of this, someone like the Honey Singh songs, Yo Yo Honey Singh, and someone like the Badshah song, Bachpan Ka Pyar, and someone like Kumar Sanu, or someone like Alka Yagnik, or someone like Sunidhi Chauhan. Why this is going to happen, please? Because each and every have the different ear, and the different ear have the different sensations. So if I can hear the KK song Yaro Dosti, so it will feel attract to my ear or produce pleasuring effect to my ear, but it is not produce each and every one for pleasuring effect. If you understand this, any question or any queries, you can write down in my comment box. Next thing is that the difference between the loudness and the intensity. So what is loudness and what is intensity? How these both are different? That is question arise in your mind. So first thing, loudness and intensity. So loudness means the degree of sensation produced on ear, that is called loudness. Whereas intensity is what? Quality or the quantity of sound flowing across unit area in unit time. It is called intensity. Loudness varies from person to person or listener to listener, whereas intensity is always same. Loudness is physiological quantity, whereas intensity is physical quantity. Now you can ask that what is physiological quantity? Physiological quantity, that means that human ear is there and that will decide that. That's why it is called physiological things, whereas intensity is physical things. All have the same values. Unit of loudness is phon or son, whereas unit of intensity is watt per meter square. So to determine the time, that is called reverberation time, one scientist come in the picture. That scientist's name is called Sabines. So basically Sabines determine the formula for reverberation time, and it will give the correct formula is T equal to 0.167 into V divided by sigma AS, where T V represent the volume of the things divided by absorption coefficient A, and S is the area, and 0.167 is the constant. So with the help of this formula you can determine the reverberation time. Now next come to this. If you have any difficulties, any queries related up to this topic, you can ask in my description box. So next thing is that factor affecting the acoustics of the building. So there are mainly 7 factors which are affect the acoustics of the building. Or if we say that to make a particular building we are concentrate on this 7 factor, then there is no problem happen on the building. First one is reverberation time. So it is the persistence or prolongation of sound in a hall even after the source stop emitting. So we can already discuss that what is reverberation time. So if reverberation time is low, sound dies. So if reverberation time is high, echo is produced. So it is controlled by either inserting or removal sound absorbing material in a hall or room. So what is going to happen here? That if a reverberation time is low, then sound is died. If I am speaking small amount of sound, then it will not reach up to you. So this is called die of the sound. And if I am speaking to very high, then echo is produced. So in this particular thing we can discuss the what is echo. Next is the loudness. So if intensity of sound is more, so loudness is more, and the intensity of the sound is less, so loudness is less. So loudness may get reduced due to the excess of sound absorbing material used inside a hall. Next is focusing and interference effect. The presence of any concave surface or any other curved surface in the hall or room may make the sound to be concentrated at this focus region. So sound may not be heard at all at other region. These regions are reflected as their space. So focusing there should not be interference of direct reflected wave, because a constructive interference may produce a sound of maximum intensity in some places, and destructive interference may be produce a sound of minimum intensity. Now in your mind, that what is focusing? So if you going to any cinema hall or any multiplex or any other things, so there is a step size indices are there. It is in the form of steps 1 2 3 like this. Why these step size indices are required in multiplex, cinema hall or auditorium? Because the interference pattern is not produced. What is interference pattern? Two waves are superimposed with each other. This phenomena is called interference. So in this particular case, why we are required the step size indices? Because you do not produce the interference pattern. So that's why the step size indices are required, or that is called focusing or interference effect. Next is echo. So it is heard due to the reflection of sound from a distant sound reflected the object. So time interval between the direct sound and reflected sound is less than 1 by 15 of a second. So the reflected sound is helpful in increasing the loudness. So this is called echo. Echo is what basically what? If your direct sound and reflected sound have the time difference of 1 by 15 second, then your original sound is joined with reflected sound, and this phenomena is called echo. Next is the fifth one, that is called Echelon effect. So if generation of a new separated sound due to the multiple echoes, so set a railing or any regular reflecting surface is said to produce the echelon effect. It is affect the quality of the original sound. So this phenomena was produced in the old cinemas or old auditoriums or old live programs are there or old structures that echelon effects was there. But right now the new technologies are there, so we do not require the echelon type effects. But we can consider the echo, reflection time and all these phenomena. Then next is resonance. So what is resonance? It is occur due to the matching of frequency. If a frequency of the two waves are going to match, then they both are in the resonance. There we can know that. So if a window panel and the section of wood portion have not been tightly fitted, so they may start vibrating, creating an extra sound in addition to the sound produced in the hall or the room. Next is noise. So there are mainly three types of noise are there: airborne noise, structure-borne noise, and inside the noise. So if we consider these three types of noise, so what is airborne noise? What is airborne noise? So airborne noise, extraneous noise which are coming from outside through open window, doors and ventilations are known as airborne noise. Structure borne noise. So it is conveyed through the structure of the building is called the structure borne noise. Structural vibration may occur due to street traffic operations of heavy machines. And third one, it is called inside the noise. It may be produced due to the machineries like ACs, refrigerator, fans and typewriters or the computer keyboards. So this is are the seven factors that we should remove or we should check once we can make a building. So this is basically used for the civil engineering students and the architecture students, or maybe the industries for the mechanical students who made the industries. So that is each and every branch you should require if you want to make a company or if you want to make an industry, then you should know the complete acoustics before you plan the things. Next is the condition for good acoustics. What are the conditions that your industry or your place or your machineries are going to very good quality? That is depends on the acoustics. The first one is quality of a sound uniform. When you are placing your machines, these machines are always operated in a uniform manner. If I am put a machine of a making some particular object, and if I am putting more than one machines and all have these different sounds, so it is not the good acoustics. Second one is no overlapping of sound is produced. There are no overlapping is going to taken place. Only one single form of a sound is produced. Loudness is uniform. If your industry is making some particular things, then the loudness of this particular way is always uniform. Presence or absence of audience should not affect the quality of your sounds. That is, your workers or any other things are there, they do not affect the quality of the sounds. Resonance effects should be avoided. Halls should have a proper reverberation time. Hall should have the proper reverberation time. External noise should not disturb the proceeding inside the hall or auditorium. External noises, if you are working in the company, so you do not hear the noise from the outside of the road, should not be any echelon effect. So these are the phenomena required to produce the good acoustics of your building, auditorium, cinema hall, of your industries or your company. That is the minimum things required. Next is site selection. So auditoriums should be away from the highways and the traffics. Auditorium without air conditioners not required. Windows and doors are kept open during the performance. AC is used, then care should be taken for the noise. So these are called the site selection for your companies, industries, auditorium or offices. Next is the volume. So floor is required to 0.6 to 0.9 meter square per person. So if you consider this and the average height of 6 meter for small halls and for 7.5 meters for large halls. Recommended the volume for different types of auditoriums. One is concert hall, 4 to 5.5 meter cube per person. Theaters, 4 to 5 meter cube per persons. And public lecture halls, 3.5 to 4 meter cube per persons. Next is the reverberation. So time and the acoustics we are considering. So if a time of this reverberation is 0.5 to 1.5, then it is called excellent reverberation time. If a time is 1.5 to 2 seconds, then it is called good reverberation or good acoustics. So if a reverberation time between 2 to 3 seconds, then it is satisfactory. If a reverberation time is 3 to 5, then it is bad acoustics. And if a reverberation time is greater than 5 seconds, so it is very bad. Next is activity in the hall. So if you make a particular hall, then how much amount of reverberation time is required, that we learn in these particular things. One is called conference hall. So to make a conference hall, the reverberation time is always set between 1 to 1.5 second. If you make a cinema hall or theater, then reverberation time is 1.3 seconds. If you make a assembly hall, then the reverberation time is 1 to 1.5. Public lecture halls, then it is 1.5 to 2 seconds. Music concert halls, so 1.5 to 2 seconds. Churches, 1.8 to 3 seconds. Large halls, 2 to 3 seconds. So this is called activities in the hall. If you make a hall, then this type of phenomena is required. Next is called the sitting arrangement. So rise in level of steps may be about 8 to 12 centimeter per room. Back to back distance of chair in successive row should be at least 75 centimeters, and this may be increased up to 100 centimeters. Angles should not be exceed 30 degree. Distance is 4.5 meter for movies watching and 3.6 meter for the theaters. Distance from the curtain line should not exceed 23 meters. So this is called the seating arrangement. Next we can discuss the sound insulations. So for good sound quality inside hall or room, unwanted sound is to be prevented. So prevention of the unwanted sound transmission energy is known as sound insulations. So if any closed surface or if a closed structure is there, so two types of sound may be creating noise inside. This can be characterized as airborne sound and structure-borne sound. So airborne sound transmitted from outside the source in a hall. This is called airborne sound. And second is structure-borne sound transmitted from the inside the structure in the hall. So if we learn this in details, what do you mean by a airborne sound? So sound transmitted from the outside the source in a hall through open space is airborne sound. This transmission of a sound is usually through doors, windows and the open structures. Sound produced by the vehicle is transmitted inside the hall through open structure is an example of a airborne sound. To control airborne sound, following arrangement can be done. So by keeping minimum air gap between the frames and doors or the windows, we can also place an absorbing material in between those gaps. Instead of unnecessary windows, transparent ventilations can be used. Curtains, insulators and papers can be used to fill the air gaps on unnecessary noise. Second is structure-borne noise or sound. Sound waves are created by structure inside the halls are known as structure-borne sound. Mainly this is created due to vibration and reflection through the walls, flooring and ceiling. Structure-borne sound is mainly due to the vibration between walls and transfer the energy to the other walls. So this phenomena you can know particularly. So the structure-borne sound is generated by the reflection of sound. Basically sound is elastic wave propagates through compression, rarefaction. This transfer energy by reflection from the structures. Noise generated by the structure-borne sound called by reducing using the following steps: by covering floor, ceiling and other structure by sound absorbing materials. To avoid the transmission of vibration energy, joints of walls should be avoided as much as possible. By creating frictions free or more rigid structure, vibration can be reduced. Noise pollutions. Next is the topic is noise pollutions. So it is regarded as unwanted sound which produce unpleasant effect on ear. When this noise produce several adverse effects on the quality of human surrounding, it is called noise pollution, and it produce discomfort to the human beings. Source of noise pollutions. Based on the source, we can distinguish noise by industrial source and non-industrial sources. So printing press, industries, machines, vehicles, aeroplanes are the source of industrial noise. This contributes on major and intense portion of noise pollution. TV, audio system, household gadgets like mixer, grinder, vacuum cleaner are non-industrial source of noise. Noise pollution is again measured in decibel. It is relative method to measure the intensity level. Due to the intense and continuous noise level, hearing issue increase along with the hearing implantations. Human being may affected from anxiety and stress reactions. It increases the blood pressure and stimulates many disorders. So this is called the noise, and how it is disturbed in our life or in our industries or in our machines and in our cinema halls in our auditoriums like this. So how this we can control this noise in machines? So it is very important for higher production and for the creation of healthy environment for the worker in the industries. It is done by focusing on maintenance, replacements of unnecessary noise producing components and few technical arrangements in machineries. This can be discussed as below by the maintenance. One is replacement or adjustment of worn or loose parts should be done. Second, lubrications of moving part is necessary. Third, balancing of unbalanced equipment will control noise. Fourth, by providing a dynamical balance to the vibrating machines. By substituting materials, by replacing some materials like instead of steel spokes in chain drives, composite fiber spokes can be used. By architectural charges, insulation of noise should be done by enclosing the source. So this can we can remove the things. So this is how about the normal acoustics that we can use in our day-to-day life. And this phenomena is followed by the civil engineer, mechanical engineer, or even the architectures, or even the automobile engineers also. So this phenomena is called the acoustics. So if you clearly understand about the acoustics, so in this particular chapter we can first discuss what is, if we revise the things, then first thing is in your mind that what is acoustics. Acoustics is the branch of sound wave which will deal with the building, machines and all the things. So this is called the acoustics. What is sound? So vibration is produced perpendicular to the surface, then sound wave is produced. Sound waves are characterized in three parts: infrasonic, frequency less than 20 Hz, audible, frequency between 20 Hz to 20 kHz, and ultrasonic, more than 20 kHz. Then there are the two types of sound waves are there: musical sound waves and the noise. What are the characteristics of the musical sound wave? We are discussing pitch, loudness, quality or timbre. What is loudness? What is intensity? Difference between the loudness and intensity is there. What is reverberation? Reverberation time, echo. These things we can learn in this chapter. We was learn in the chapter. Next is what are the affected things, that is 7 things which are affect the acoustics of the building. What are the phenomena to become a good acoustics? What is the noise and how this affect the noise? What are the airborne noise? What are the structure borne noise that we was discussed in this particular video? So now you can clearly idea about the basic of acoustics. If you have any queries or any difficulties, then you can ask in the description box. So, my name is Sah Nirav Kumar Sasikant, and I am the owner of Jain Classes. So, if you have any difficulties or queries, because I am just only run these online videos on my YouTube, that is called Jain Classes. This video is only useful the particular students who are working in the field of acoustics. So if you have any difficulties or any queries, you can write down in my description. We can solve the further way. Thank you for watching my videos. Signing signing off by myself, Sah Nirav Kumar. Once again, thank you and very grateful day to all of you.